Be talking about silk fiber formed in silkworm cocoons during cultivation. Firstly, silkworms are classified as Bombyx mori, and during my presentation, I will be focusing on domesticated silkworms that are used solely for the purpose of silk fiber cultivation. The reason why I've chosen to do this is because in the wild, each cocoon is different based on that larva's certain surroundings and needs. They will produce a different cocoon based on their predators, their temperature, and the environment that they're in. Firstly, I want to talk about the stages of a silkworm cocoon, which is called sericulture, to give a bit of background information. So, step number one, the silkworm spins the cocoon from two glands called the spinner, located on its head, and it shoots this out, which creates the initial first layer of the cocoon. So, number two, once it has contact with air, it forms this protein material called fibrine, which hardens it and compacts it around the larva. In stage number three, a production of sericin from another set of glands binds these fibers together that were initially created from the spinneret, but it doesn't weave them together completely. In step number four, the death of the larva is due to the heat produced in the cocoon, and it makes it easier when it comes time to harvest. Stage number five, the sericin that was produced in stage number three is softened by a warm water bath to prepare for harvesting. Another way that it can be harvested is in stage number six, when the silk fiber is harvested and twisted together to create a thicker strand used for materials, silk, and in clothing. So the difference between the bulk and molecular structures are that the cocoon is made out of different strands of silk fiber chains. The cocoon is different per larva, and it can be unraveled to create silk or degumed, which is the warm water process, and where the sericin is extracted. In the molecular structure, the different strands made from silk fiber chains are not woven together, but they are bonded by the sericin bonding matrix. The particles within these silk fiber chains are different stacked amino acids, and once stacked together, they create the strong protein material fibrine. I will go into more depth about the molecular structure in my model. So here is my bulk image of the cocoon. As you can see, here are the different strands of this silk fiber. These strands are made up of chained silk fiber particles, and as I've made right here in my model, these are those right here. These are the different chains. This in the middle is the sericin bonding matrix, and as you can see, it is not. You can see that they are not as strong as here, which comes later in my CER. So these silk fiber strands are made out of the protein material fibrine. In my zoom in bubble over here, you can see that these strands are made out of the protein material fibrine, but that protein material is made out of three different amino acids, which are glycine, alanine, and serine, and these come together to create that long silk fiber strand. So my CER question is, how does the molecular structure relating to cocoons of Bombyx mori affect their harvesting? And my claim is that the cocoons are prepared in a specific way and are monitored in a specific setting to speed up harvesting time. As I've said before, the silkworm cocoon is made up of silk fiber strands, made up of silk fiber chains. Silk fiber is made up of protein material called fibrine, composed of various amino acids. And this silk fiber makes up a longer silk fiber strand, and which are lightly bonded together with the sericin bonding matrix. So my reasoning for this is that In a closed system, the larvae are monitored and bred for the sole purpose of extracting the silk fiber. Since each larva creates a different cocoon depending on the environment that it's in, it is very crucial that you look at cocoons that are bred in a closed system to really understand the different forces happening inside the cocoon. They are prepared in this way to make it easier to unravel and to speed up the harvesting time, because if they are heavily bonded together, which is what happens when they are in the wild, because of the different variables that affect the way that the cocoon is made, it will be harder to unravel and unreel. That is why there are these special cocoons and special settings to grow these larvae in, so that they can be used for harvesting. So, as I said before, there are strong intermolecular forces between the amino acids that make these silk fiber chains very, very strong, but they're weak between the different fiber chains connected by the sericin bonding matrix. That has a weak, those have weak forces binding the different strands together. In the wild, it would be different. So this matrix is responsible for the unwoven silk fiber chains, and because it is like this, they can be easily degumed or reeled off the cocoon depending on which process that certain farm uses. Here are my sources. I'll be going more into detail about my Encyclopedia Britannica one that I turn in, but thank you for watching, and I hope you enjoyed this video.